Okay, today we are talking about what all of you actually wanted to know for a long time, and that is latent heat. Right, we shall just take a look at what is latent heat with the help of an example. Suppose we have a vessel, and this vessel, suppose as usual, it contains some water, and we are going to say heat this water. And before heating this water, what we are going to do is we are going to put into this vessel what we call a thermometer. So let us draw a thermometer here. Okay, a thermometer is an instrument for measuring the temperature of any substance. It consists of a bulb filled in with mercury, and as it is brought into contact with the substance whose temperature is to be measured, the mercury in this bulb expands and it rises in the tube, and we can read the temperature reading due to the marks that are there on the tube, and in this way we can measure the temperature. So this is the thermometer. Here in this bulb, this is as the bulb containing mercury, and this is the thermometer. Okay. So, and what we are going to do, we are going to put this thermometer into this thing like this. And after we have put this thermometer into this water, we are going to heat this water. So here we are going to heat it. So this is we are supplying heat. Now what actually happens when we are going to heat this? We see that when we heat it, the temperature of the water rises, that is the mercury column rises. So we're going to write it down one by one what is going to happen actually. So first thing is, number one, on heating what happens? The temperature rises. Now why does the temperature rise? The temperature rises because the heat supplied is transferred to the particles in the liquid. Now, do you remember what is the nature of the particles inside the liquid? Inside the liquid, the particles are not bound to any mean position. Rather, they are free to move about within the volume of the liquid. Okay. Now when we heat this substance, what happens? The heat supplied is transferred to these particles and their energy increases. And the increase in energy of these particles is seen as a rise in temperature in the thermometer. So we can write the temperature rises. And why does it rise? It rises because the energy of the particles increases due to supply of heat. Okay. So energy of the particles increases due to supply of heat, and hence the temperature rises. Now we have seen that if we go on supplying heat, what happens? If we go on supplying heat, there comes a time when all the particles inside this liquid, they start getting converted into the gaseous state. That is, they break away from the bonds of attraction between themselves, the other particles of the liquid, and they can now escape from the volume of the liquid, and that is, they have changed into the gaseous state. So when that happens, that is when all the particles inside the liquid are simultaneously changing into the gaseous state from the liquid state, we have a situation what we call boiling, and that takes place at a fixed temperature. Okay. Now, when we reach that point, that is when we reach the point of boiling, we will see that the temperature of the thermometer shown in the thermometer becomes constant at some point. Now, in the case of water, this temperature is about 100 degrees Celsius at normal atmospheric pressure. So at around 100 degrees Celsius, when water starts to boil, the temperature does not rise any further, although heat is still being supplied. So we'll write that down. What happens? What happens is, although heat is being supplied, the temperature does not rise. When water starts boiling. Okay. Now, why does this take place? Why instead, although heat is being supplied, the temperature is not rising? Because at that point of time, what is happening? The heat supplied is being used to break the bonds of attraction between the particles and change the state of the particles from the liquid state to the gaseous state. So now at this point of time, the energy being supplied does not increase the energy of the particles, rather they are used up to change the state of the particle. That is, the bonds of attraction are broken and the particles are converted from liquid state to the gaseous state. So this heat which is used up to change the state of the particles from liquid state to gaseous state is not seen as rise in temperature. So that we will write down over here. So that is the fourth point. The heat supplied during boiling is not seen as rise in temperature. Okay, it is not seen as rise in temperature because it is used up for changing the state of the particles from liquid to gas. So actually what happens is, hence we can say that, hence we can actually call it in that way, that this heat, since it is not seen as a rise in temperature in the thermometer, we can say that this is hidden heat. So this heat is not seen, it is hidden. Hidden has another word, that is latent. So we can also call it latent heat, that is hidden heat, because it cannot be seen as rise in temperature. So we'll write it down that since this heat cannot be seen as rise in temperature, it is called latent heat or hidden heat. Okay, so in this case, this latent heat is being used up to change the state of matter from liquid to gas, and so in this case, this latent heat is called latent heat of vaporization.